Hello everyone. Welcome to this course on Terraform. In this course, we are going to learn everything about Terraform starting from the scratch. So even if you are new to Terraform and know nothing about it, don't worry, as we'll be starting from scratch and be learning about Terraform. Okay. So before I get started, let me just give you a brief overview of what is covered in this course. In the first section, we will talk about infrastructure as code because that is very fundamental to understanding what Terraform is. Okay, so I will introduce you to the concept of infrastructure as code, and then we will talk about Terraform. Okay, so once we have understood that, we will go ahead and install Terraform in our Windows or Mac laptops. And after installing, we will learn about the Hashicorp configuration language, which is a language used to define your resources or configurations in Terraform. Okay, so you will use this language to define your resources that you need to create using Terraform. Okay, so we will learn the basics and syntaxes of this language, and then after we have learned this, we will use this knowledge to deploy a simple web application to AWS using Terraform. Okay, so this will help us get some hands-on experience on how to use Terraform with AWS. Okay. Now, before I introduce you to Terraform, I want to talk a little bit about infrastructure as code. Okay, so this concept is very much important before we start with Terraform. So, infrastructure as code is the process of managing and provisioning infrastructure through code. Okay, so before we dig deep into this definition, let me take you through an example to make you understand this concept. Okay, so let's imagine we are hosting an web application on Amazon EC2. Okay, so I'm just showing so your application is hosted on EC2, and like users will be able to access this application through internet. Okay, so let's see what are the resources that you would need in AWS to run your web application on EC2. Okay, so firstly, you would need an EC2 instance, and second, you would need a security group to define the rules like who is allowed to get into your instance and what traffic is allowed in and out of your instance. Okay, and third is you would need a VPC in which you will create your EC2 instance. Okay, so these are the resources, minimum resources that you would need to run a simple web application on Amazon EC2. Okay, so now how would you create this resources? Okay, so you can create these resources like any number of ways. You can create it using a console, or you can create it using about 3 APIs, cloud formation, and many other ways. Okay, so let's imagine you are creating it manually. Okay, so but your application needs to be deployed into different environments. Okay, so you will create this in dev. Okay, but you will need to create the same set of resources again in UAT or testing environment. And again, once your application is tested, you would need to create the same set of resources in prod. Okay, so you would need to do this like in all the environments. There is like a few challenges associated with this, like how do you maintain the consistency across all the environments? Meaning you would create the same type of instance, and you define the same security group rules and all the stuff. Okay, and why how do you avoid the redundancy of doing this again and again in different environments? Okay, what if there was a way like you would write a piece of code which you would run in all the environments? Okay, so you define let's ignore the syntaxes and the technicalities of the code for now. Let's imagine that like you define these resources in some code, and this code can be run in all the environments like dev, UAT, and prod to create the same set of resources with similar configurations. Now, if you wanted to do any update to basically, let's think about the EC2 instance. If you want to increase the size of your EC2 instance, you would just need to update this code and run this code in all the environments, and it would update the EC2 instance to the same like class in all the environments. Like any other configuration change, right? You just need to update this code and run it across environments. So there are a lot of other advantages as well. It like it is it is better to manage, it is good for maintaining consistency, and lot of other advantages as well. So this is the concept of infrastructure as code. You define your infrastructure or resources in a piece of code. It can be like anything. Okay, there are a lot of tools available infrastructure as code tools available. So you can define your code or configuration in that tool, and then you can run it across your environments to create your resources. So this is the concept of infrastructure as code. Okay, so let's take a look at a few infrastructure as code tools that are available. There is Ansible, Puppet, Chef, and AWS as its own tool, which is CloudFormation. You can define your resources in a, YAML format and run it in CloudFormation. It will create the resources. And then there is Terraform. Okay, so there are a lot of other infrastructure as code tools as well. Okay, so now that you have understood, what is infrastructure as code, let's see some salient features of infrastructure as code. Okay, so it helps us manage infrastructure using code. Okay, so you write some code and you manage your resources using this piece of code, and it automates the process of provisioning and configuring infrastructure. So all these manual steps of like updating your infrastructure and creating it, provisioning it, is avoided using infrastructure as code. Okay, it automates the process, and it ensures the consistency and repeatability across environments. So this point we already discussed in the previous slide. Okay, so now when there are so many tools that are available, infrastructure as code tools available, why Terraform? Okay, so why should we pick? Because we are running our web application in AWS, right? So why not use CloudFormation? Why use Terraform? Okay, so let's see some important features of Terraform which make it stand out when compared to other infrastructure as code tools. Okay, so Terraform is provider agnostic and multi-cloud support. Okay, so if your application has some resources which need to be created in AWS, Azure, or like any other, on-premise or whatever, right? So you can define all the resources in Terraform. Suppose you are using CloudFormation, you cannot define your like local on-premise resources using CloudFormation, right? So Terraform is provider agnostic and multi-cloud support. So it provides like almost all the servers, all the provider. It supports all the providers like Google Cloud, Azure, and whatnot, right? And it has a very declarative and intuitive language, which is Hashicorp configuration language or Terraform language. Okay, so which is very easy to write and maintain. Okay, so we'll discuss more about this language later. And the other thing is state management. So Terraform the maintains the state of your resources. So if you deploy your resources now and someone manually updates the resource in AWS, whatever in console, right? Terraform it will maintain the current state of your resources, and next time when you it identifies a drift in resources. Okay, so we will talk more about this feature later, but this is also a very important feature of Terraform, which is management, which it maintains the current state of your resources. Okay, and it allows for a modular design, so you can write reusable modules. You can think of modules let's say classes in coding, so you can define modules and then reuse those modules across your code to create set of resources. Okay, and Terraform is open source and it has a very large active user community, so you can get help if you're stuck somewhere when using Terraform. Okay, so these are the major features of Terraform which make it stand out when compared to other infrastructure as code tools. Okay, so now let's see how Terraform works in a nutshell. Okay, so this is a very basic flow of how Terraform works. Okay, so you will have your resources defined using code. Okay, so you will create like this code or configuration files. uh, okay, then what Terraform does is it takes these files, it interacts with the provider. Okay, the provider can be AWS, Azure, Google Cloud, or any other Kubernetes, or your on-premise resources as well, right? So it interacts with the provider using the provider APIs. Okay, if it is if you're creating AWS resources, it interacts with AWS using AWS APIs and creates these resources for you. Okay, so it figures the beautiful thing about Terraform is it will you don't need to think about how the resources are created. It is a declarative language. Okay, you just declare what you need, the resources that you need, the state of resources that you need, and Terraform in the backend will interact with the provider using provider APIs to create those resources for you. How it is done is up to Terraform, and it will take care of it. If there are any dependencies between the resources that you are creating, that will also be taken care by Terraform. Okay, so this is how a simple flow of Terraform works. Okay, next let's see how to install Terraform in your Windows or Mac desktops. So this is important for us before we go to the next step of learning the Hashicorp or Terraform configuration language and start writing some code. Okay, let's see how to install Terraform on a Windows machine. So just go to your browser and search for download or install Terraform in your browser and click on this link that appears. So here you will see options for different operating systems like Mac OS, Windows, and Linux. So we want to download it for Windows. So if you are on a 64-bit Windows, just click on this AMD 64 download, and so this zip will be downloaded. Just click on open file. Okay, so basically this is the zip file that we downloaded. I'm going to extract this to a location. Click on extract all, and I'm going to extract it to this path C. Okay, and inside that C I'm going to install in directory called Terraform and click on extract. Okay, so now we have extracted it to this location. So we need to add this path to the environment variables before we can start using Terraform. So search for environment variables. Okay, click on this and click on environment variables and go to the path variable and just click on new and add the path that we extracted the Terraform to, which is C colon, I think it should be backslash. Let me just, okay, so it is C colon backslash and Terraform. Okay, add it, click on OK, and okay. Okay, so now to verify that Terraform is installed properly, let's go to terminal and run like a simple Terraform command. Let's just run Terraform help. Okay, so if you see here, we are getting the Terraform like output for the Terraform help command, which is basically the commands that Terraform supports. Okay, so if this command runs successfully, it means that you have installed Terraform properly in your Windows machine. Okay, so let's see how to install Terraform on a Mac. If you're on Mac, just Google for install Terraform in your browser and just click on this link that appears. So here you will see the binaries that are available for download. If you are on Intel chip, you can download this version, or if you are using Apple based like Silicon chip M1 or M2, whatever, you can download this ARM64 package. Okay, so I'm just going to download this one. Okay, so I'm going to unzip the file that I downloaded here. Okay, and I'm just going to rename it as Terraform. Okay, so if you see, there is an executable file here. Okay, so next what I'm going to do is I'm going to move this executable from downloads to my user local bin so that I can execute it. Okay, so I'm just going to move this from downloads, this executable from downloads to user local bin, and once it is done, you should be able to run your Terraform commands. So I'm going to verify the installation by running a simple Terraform command. Okay, so yeah, we are able to run this command, so we should be good here. So okay, now let's take a look at this Hashicorp configuration language, also called as Terraform language, and see what are its features and what is the syntax of this language and how to write your code using this language. Okay, so this is a declarative configuration language created by Hashicorp. Okay, so what is the meaning of declarative? It means that we do not specify any logic or like any process of how this resources will be created. We just declare the resources that we need in a configuration language, and these resources will be created by Terraform. That is the meaning of declarative language. Okay, so we just declare our resources like this. In this example, we are just asking the Terraform to create an AWS S3 bucket with this bucket name and these tags, and Terraform will create this resource. Okay. So this language is designed to describe and manage infrastructure resources in a human readable format. Okay. So this provides a code and configuration syntax, and the configuration files that you write in Terraform. So it tells the Terraform what plugins it needs to install, what infrastructure it needs to create, and what is the data that it needs to fetch. Okay, so we will see how all this happens when we write the Terraform code and execute it. Okay. Uh, so we can also define dependencies between resources. So if you have certain resources like in your application where one resource depends on the another, so you want to create this resource only after some other resource has been created, you can specify that dependencies in your Terraform code, and Terraform will take care that the dependencies are met. Okay. You can also define reusable modules. So if you have like let's say a module which consists of certain resources which can be reused in many other places in your application, you can define those modules and reuse it. Okay, so just to show you some basic syntax of this Terraform language. So any like Terraform language code consists of what is called as blocks. Okay, so this thing you see here is a block. A block has like four sections. So one is a block type. Okay, so here the block type is resource, and the label of the block. It is AWS VPC. So this is basically the type of resource that you're creating. If it's a bucket, you will have AWS bucket and so on and so forth. Okay, so this is the block label, and this is also a block label. It's basically identifier for that block, and then inside that you will have the block body, which is basically key value expression. So you will have an identifier and an expression for that. Okay, so your block type can be a variable or a resource provider data, and it can be many other things which we will see when we write the code. Okay, and your arguments are basically here the key value pairs inside a block. Okay, that define basically the attributes of that resource that you are trying to create. So if you see an example here, I mean, don't worry about the syntax and everything. I will walk you through in detail. I just wanted to show you here, like one example of the block. So here we are creating a resource, and the resource type is AWS instance. Okay, so you will basically every resource has a resource type. If it has a EC2 instance, it's basically AWS instance. So you can get this from the Terraform documentation. I'm going to walk you through that as well. And this is the like identifier of your resource web app instance. Mind you, this is not the name of the instance, and these are basically the key value pairs that going. So what is the AMI, and what is the instance type, what is the subnet ID, security groups, user data, and all those things. Okay, so this is just one example. I'm going to create one Terraform project and start writing a code step by step so that you can understand in more detail. Okay, so let's learn the syntaxes of this language hands-on by deploying this web application on to Amazon EC2. Okay, so we will create all these resources that are required for this web application. So we will create an EC2 instance, we'll create a security group, and we'll try to deploy this inside a default VPC itself. So let's not create additional VPC, but yeah, let's deploy simple these resources using Terraform so that we'll get some hands-on experience on how to use Terraform. Okay, so let's start writing the code to create those resources needed for the web application. I have created a directory in my Visual Studio Code. So I'm calling it Terraform tutorial. So inside this directory, I'm going to add all my Terraform files. Okay, so firstly, let's create a file called as resources.tf. You can call it whatever you want, main.tf, webapp.tf, whatever. Okay, so this will contain all the resources that we want to create. Okay, so any Terraform file should end with .tf. Now, what are the resources that we need for this web app? We need a security group and we need an EC2 instance. So how do we know what is the syntax to create a security group and EC2 instance in Terraform? Okay, you can refer to a Terraform official language, official documentation itself. So if you search for Terraform security group, so this will give you examples. So there is like very in-depth documentation available for each of the resources. What are the arguments that you can pass and all those things. Okay, so we'll just copy this one for syntax and paste it here. So like we discussed earlier, so this is a block type which is a resource type, and this is the block label AWS security group, and this is your like the name of your block, like the resource. Okay, so let's call it as web app security group. Okay, let's call it as web app sd. Okay, you can add whatever description that you want. Web application security group. Okay, so next is VPC ID. What is the VPC that you want to deploy this security group in? Okay, we will come back to this one. So this is basically the tags. You can add whatever you want, like the tags. So you can add this is basically to track your application resources. Okay, so these are the basic attributes. So you can also add many other attributes. So what are the inbound and outbound rules of this security group? For that also you can find the syntaxes here. So if you see here, they have resource AWS security group ingress rule, also egress rule, which is the outbound rules, and then you can also add security groups like this as like this as well. Okay, so I'm going to add the ingress and outbound inbound and outbound rules like this. So I just have saved this, made a note of this just to save some time. Okay, so I will paste them here. So basically these are the inbound and outbound rules of our security group. So I'm allowing all the traffic on port 80 and 22 from all the IPs. So make sure you just give this based on your requirement. And I'm also allowing outbound traffic on the like all the ports to all the IPs. Okay, so I just want this web app to be accessible from the internet. So what we have done is we have created a security group called as web app sd. So this will be the name of the resource after creation. In this VPC ID, I will come back to this VPC again with these inbound and outbound rules. Okay, so now we have created a security group. So next thing we need is we need an EC2 instance. For that also you can just Google for Terraform EC2 instance example and you will find it. Okay, so you can find like the syntaxes and the attributes for any block type or any resource in this one. Okay, so let's take this as an example. Okay, you can take this and this AWS instance, sorry, and we will call this as web app instance. Okay, so this AWS instance and this AWS security group needs to be this like exactly same. This naming convention itself, because it's basically the type of resource that you are creating. Okay, you cannot change this based on your wish. However, you can name this however you want. Okay, this is your identifier. Okay, so the next thing we need to specify is what is the AMI, Amazon machine image of the instance. Okay, I'll come back to this one as well. So I don't think we need all this, so I'll just remove. So this is the instance type. Let's modify this instance type. Let's create a t2 dot micro instance, and let's modify the tag of this one and keep it. So let's keep the tags consistent across all the resources. Okay, I will come back to this EMI. So let's specify some more parameters like subnet ID. So what is the subnet ID that you want to create this in? Okay, yeah, I'll populate this later. And what is the security groups? Okay, I'll populate this as well later. And one more thing that we will add is user data. Okay, so this is basically the startup script that gets executed when we run this Terraform. Okay, so I have this saved here, so I'll just add it. User data script. So basically what I'm doing is I'm just installing the HTTPD server and just writing some sample index.html so that we can test this web application after we have deployed it. Okay, I'm just starting the web server, things like that. Okay, so so the next thing that I wanted to highlight is so we are specifying this VPC ID, the subnet ID and security groups and all those things here, right? So instead of hard coding this, what if we can just pass this as a variables so that like, I mean, all these variables are tracked and maintained in a separate file. Okay, so for that, what I'm going to do is I'm going to create a file called as variables.tf, and I'm going to define my variables there. Okay, so I'm going to call variable um, instance type. Okay, uh, and I'm going to pass a default value for that one. Okay, so what is the default value of this? Okay, so here we will make it as t2.micro, and we'll update the resources.tf file to refer to this variable. Okay, I'll create another variable called as region. Okay, and I'm going to default it to let's say US East 1. Okay, so this is my default region, and we can like basically parameterize anything that we want. Okay, we can also parameterize variable AMI and default. Okay, so we will get the AMI from Amazon later, like from AWS marketplace. Okay, so like this you can define any number of variables. So once you have defined it here, you can go to this resources. So if you want to refer to this instance type like from the variable, right, so you can call it like this, var dot instance type. Okay, so this is how you refer to the variable in your Terraform code. So this is how you define your variables, and this is how you refer. Okay, so another thing that I want to highlight, I want to dynamically fetch the VPC ID of my default VPC. Okay, so for that, what I'm going to do is I'm going to create a file called data.tf. So I'm doing this so that I can show you different block types in Terraform. Okay, so I'll come back to the CMI later. So in data.tf, what I'm going to say is I'm going to tell Terraform what is the data that it needs to fetch. Okay, so data and AWS VPC, so it needs to fetch okay, so default, and so I'm going to say it as default is equal to true. Okay, so this, it fetches basically the default VPC, and next data that I need is I need AWS subnet IDs. So you can I mean, get the syntaxes of all these from the documentation, like I was telling you. Default. Okay, so I'm just going to tell what is the VPC ID of this data dot AWS VPC dot default dot ID. So what this is basically it will fetch the subnet IDs. Okay, and then you will have which is a subnet. Okay, AWS subnet. Yeah, we are fetching basically the default subnet. ID is basically data dot AWS subnet IDs dot default dot IDs of 0. Okay, so this will basically give us the subnet ID of basically the first subnet ID of the default subnet. Okay, so these things will be dynamically fetched from your AWS account. Okay, so we will go back here, and in the VPC ID, instead of keeping it like this, what we will now do is we will refer it from the data file. Okay, data.aws-vpc.default.id. Okay, so this is the default VPC ID, and similarly here as well for subnet ID, what we will do is AWS subnet.default.id. Okay, so this will populate the subnet ID of the default subnet. Okay, similarly for security groups as well, you basically the security groups, you need to refer to the resource that was created here. So what we will do is we will AWS security group dot web app security group dot name. So basically once this is created, you will you can refer to this web app dot name in your other resource. So this is how you can refer to the resources which are created inside your code in other resources. Okay, so I think this should be good. We need to add another file called as provider.tf, which will basically tell what is the providers that AWS needs to use uh, for this project. Okay, so since we have only one provider here, provider, we will call it AWS, and you can specify the region parameter, which is a default region. So we can refer to var.region that we initialized in resources, sorry, variables. Okay, so we need to do another thing. We need to basically fetch the AMI from AWS marketplace. So let's do that. So okay, I have logged into my AWS account to get the EMI Amazon machine image of a Linux instance. So here it is. So I'm just going to copy this and paste. So we need an Amazon Linux instance. So I'm going to paste this one here. Okay. So now we are good from a code perspective. Okay. So, but before we can execute this code, we need to configure something. So basically, when you execute this, how does the AWS know on which like how does the Terraform know on which AWS account it needs to execute, and how does it authenticate into your account, right? So for that, you need to configure your AWS account in your local machine. So for that, what I'm going to do is I'm going to go into an IAM service, and I'm going to create an IAM user for this Terraform, and we are going to use that for authentication from our local. So I'm going to create an IAM user here. So let's call this Terraform user. Okay, so we are not going to give this user management console access. So we'll attach policies directly. I'm going to give this user administrator access, but make sure you give like fine-tuned access for your use case as required. But this user needs to have all the permissions that are required to create the resources that you specify in your Terraform code. Okay, so let's click on next and click on create user. Okay, so we have created this user. Okay, so for this user we need to get the credentials, and we need to configure these credentials in our local. Okay, so let's create an access key. We were planning to use, so let's select CLI, or you can select third party service as well. Okay, next TF. Okay, create access key. So now the access key and secret access key are created. Okay, so once you have this access key and secret access key, you can go to your local and run AWS configure. Make sure that AWS CLI is installed in your machine. So if you don't have AWS CLI installed, please go ahead and install it. AWS configure, and it will ask us for access key and secret access key. Okay, so it is asking for the key ID, which is this one. I'm gonna paste it here. Make sure that these are stored in a confidential place. Okay, I'm going to delete this user later, so it's fine. Okay, I'm not going to specify any default region. So yep, now I have configured my AWS IAM user in my local. Okay, so now let's go back to our project that we were creating. So we have defined all the resources here. So before we run, I wanted to highlight another concept here as well. Okay, so there are like 3 steps involved whenever you're creating your Terraform resources. Okay, so these are 3 main commands in Terraform. Okay, so one is Terraform init. So when you run this command, Terraform basically initializes all the plugins that are required to execute your code. Okay, so it will see what is the provider that you are using. So in our case, we are using AWS. So it will install all the plugins that are required for that provider. And when you run Terraform plan, it will basically run a plan of your resources and show what are the resources that will be created, and if you're removing any resources from your code, it will show what are the resources that will be deleted or modified, etc. Okay, so once you are okay with the plan, you can go ahead and run Terraform apply. So when you run Terraform apply is when the Terraform will actually go ahead and create those resources in your AWS account. Okay, so if you want to like destroy like or delete everything, you can run this Terraform destroy command to delete the resources. Okay, so let's come back to our project and let's run those Terraform commands to create the resources. Okay, so I'm going to open up a terminal here and run Terraform init first. Okay, so when I run Terraform init, it is basically installing this plugin. So Hashicorp AWS plugin it is installing. So once it is done installing all these plugins, we should be good to run Terraform plan. Okay, so we will wait for this to finish. Okay, so if you see here, now the Terraform has been successfully initialized. Now the next thing that we need to do is we will go ahead and run Terraform plan. Okay, so there is some issue with this. Okay, so it says AWS subnet IDs default. AWS does not support data source AWS subnet IDs. Okay, looks like there is an issue with this AWS subnet IDs default. So let's see what this issue is. Okay, it's saying that does not support the data source. Okay, so I'm going to search for AWS subnet Terraform data. Okay, and because we need it as a data source. So here, okay, so this is the syntax that we need to use apparently. Okay, so let's copy these two to replace this. Okay, okay, so let's call this as default, and we are going to filter based on VPC ID. Okay, and so the value of that VPC ID is going to be this one. So basically we are fetching the subnets of this default VPC ID, and so we just need one value. So I can just put ID equals data dot AWS subnets default dot IDs and 0. Okay, so this should be fine. Okay, so now let's save this and rerun Terraform plan. Okay, yeah, my bad, I forgot to remove this old piece of code. Okay, a data resource has not been declared in the root module. Okay, a data resource has not been declared in the root module. Okay, yeah, I think I had to name this default. Okay, just run it again. A data resource AWS AMI web app instance. Okay, I think here in instance we are still referring to the same, so we are going to refer to var.emi, which is coming from here, and run Terraform plan again. Okay, so now the plan is executing. So if you see the output of the plan, now it is showing what are the resources that will be created. So it's saying AWS instance web app instance will be created with these like parameters, and a security group will also be created with these parameters. Okay, so you can review the plan, and if you think that the plan looks good, you can go ahead and run Terraform apply, which will start creating the resources. Okay, so let me enter yes to approve this. Okay, so this is the state file that got created. Okay, so this state file will have all the state of your current infrastructure. Okay, it looks like we had an, okay, creating EC2 instance, operation error, run instances, HTTP error. Okay, invalid the parameter group name cannot be used with the parameter subnet. Okay, let's see what this is. Okay, I think the issue is with this security group, so I think we should use VPC security group IDs instead of security groups. And instead of name, we should use ID. I think that should be fine. I think that's what it tries. Okay, so let's save this and run Terraform apply again. Approve this. So it says it is creating the web app instance now. So let's wait for this to get finished. So it's taking some time to create the instance. Okay, so it says that it has created. So basically this is the state file that I was talking about, which maintains the state of your resources. Okay. Okay, so now let's go to our AWS console and verify if there's instances were created, instances in the security groups, and let's see if that web app was deployed. Okay, so there, yeah, so there's this is the instance that is running, and would have also created the security groups of this instance, for this instance, with the outbound rules and inbound rules that we specified, if you see here. Okay, so yeah, this is how you create resources using Terraform in AWS. Okay, so if you want to delete the resources, you can go ahead and run Terraform destroy, which will basically delete all the resources that are there in this code. So this is how you can create and destroy resources using Terraform in your AWS account, and this is how Terraform can be used to basically manage your resources and automate the resource deployment to your AWS account. So if this app needs to be deployed to let's say prod, or let's say test environment, you can just update the variables to a different EMI, or let's say different region, different instance type. You can deploy it to any environments using the same code. Okay, so that you will keep a track of your resources configurations and the resource size, etc., in at one place. Okay, so in this video, I hope I was able to give you a clear idea of what Terraform is and how it works, and how you can define resources using Terraform configuration language. If there is any particular topic that you would like to know more about Terraform, please let me know in the comments, and I'll try to make a video on that. Okay, thank you. That's it for this video, and I'll see you in the next one.